Welcome back to the new lecture. In this lecture, we are going to discuss about transforming data. DataWeave 2.0 is a Mulesoft expression language for accessing and transforming data. Why not Java? Mulesoft claims that DataWeave is faster than Java and has added advantages. We can transform data from any format to any other format, for example, JSON to XML, XML to CSV, JSON to CSV, and so on. Why we need the transformation? Let's see that you have integration system. You are receiving requests from one source and you have to send the modified, transformed, updated data to the system 2. In that case, you need to take care of the transformation. Or even while you want to add data in the database might want data in a particular format. So you might want to change it at that place. MuleSoft has taken care of most mule jobs. Mule jobs is repetitive jobs. So your tool takes care of those jobs, right? Like, for example, we create HTTP connection, JDBC connection. So you just drag and drop the palette and you can access the code which is required to create the connection. But the soul of MuleSoft is DataWeave language. So whatever additional you need to do, which is the unique job, not the mule job, that is handled in DataWeave. So if you must understand DataWeave to even work in real life project. We can access any specific field inside a payload using DataWeave. For example, whenever we are receiving payload, if we want to access it, we access it using payload.name. So that is also DataWeave language. Basically, we can do all kind of extraction and transformation using it. The basic format of DataWeave looks like this. You get some input. Here in this case, it is, for example, first name Max, last name Mule. Then in transform part is the one that you need to take care in your code, and output is the one which is required by the next system. So in this case, input is in JSON format and output needs to be in XML format. Now in transform, you will be writing this code inside your transform activity. In that, you will see first the header. Header contains directives that apply to the body expression. So first it will show you DW2.0, that is the latest version of DataWeave, and then comes output application/XML. So this part tells that in which format you want to transform your input to. It's so simple, right? You just give application/XML and MuleSoft is already taking care to transform it. You just need to follow a few syntaxes, correct syntaxes. After that comes these three dotted lines, three dash. So those are delimited to separate header and body. Above header, above this dashed lines would be your headers, and below that everything is your body. In the body, you will have actual DataWeave expression that is generating the output structure as required. For example, here in input you have first name, but in your output you want f name. So here you are transforming it. How? You are saying f name colon payload dot first name. So you are assigning value of payload dot first name to f name here, and same with the l name. It's very important to identify difference between object and array. Object is always enclosed with these two curly braces, and it will always contain a key value pair. Let's see few example and let's guess if it is a correct object or not. It must be enclosed in curly braces. So all these four are enclosed in curly braces. So first condition is met. Now let's say second condition, it must contain key value pair. So in first name colon Mangesh, yes, condition is met. So it is a valid object. In second one, it is name colon Mangesh, comma ID colon 2. So here we have two key value pairs separated by comma. So this is also correct format. Then comes Kalyani. So either it is key or value, we don't know. So in this case, this is not a valid object. And next one is name colon Kalyani, comma 2. So name colon Kalyani is correct key value pair, but comma 2, we don't know if it is key or value. So this is also not a valid object. This I have shown with very small examples, but even for lengthy looking examples, you should be able to guess it correctly if you just see the enclosed braces and key value pair. Now let's understand array. An array is always enclosed with square bracket, unlike object, and it contains only values. So here are again multiple examples that I have given, and we have to find out if it is an valid array or object. So first one is Mangesh, comma 2, comma Mulesoft. So these are three different values separated by comma. So it is a valid array. Next comes name colon Mangesh comma Deshpande. So in this, the outer one, if you have guessed it already, is object because it is having name colon value, and value is an array because in value it is enclosed, it is an array, it is enclosed in square bracket and it has multiple values. So inside one is a valid array. Then comes third one, name colon Mangesh in square bracket. So colon makes it name value pair. So are name value pairs allowed in array? No, only values are allowed. So third one is not an array. Now comes map and map object. Map operators is always used to access arrays inside your DataWeave, and map object is used for objects. You cannot use map object operators for arrays, and you cannot vice versa, you cannot use map operator for your objects. Dollar gives the value of field value or the key, and dollar dollar gives index of the field. So this is just revision. You already know the concepts. Let's say important operators here. We have different operators in DataWeave like map object, reduce, plug, flatten. These are again to name just few. Now can be applied on input which are. So map, as we discussed in earlier slide, can be applied only to arrays. So if your input is array, only in that case you can use map operator. For objects you cannot use map. So to extract value of arrays in input, you need to use map. For output type, so when you have array as input and you use map operator, then what would be your output as type? Array. So this is exam question. Ensure that you remember it correctly. So output of map would always be array and output of map object would be object. So it is quite simple to remember. Map input is array, output is array. Map object, input is object and output is also object. Map is used for array, can be used for array of objects, and map object can be used for here output is an object, right? Now I would just want to touch it once, but in exam mostly you wouldn't see questions on reduce or plug. So reduce is to reduce, it is applied on arrays and you can reduce the array list to anything to reduce it into given expression. And plug is used on objects. It is exactly same as map object. It is used to access object, but if you want your output as array, in that case instead of using map object you will have to use plug because your output needs to be array. Okay, and then flatten, we have seen flatten use inside your scatter gather. What does it does? It is applied on arrays. We used to get multiple different arrays and we wanted to merge them together. So from multiple arrays it makes it a single set of array. So flatten is used to turn multiple sub arrays into a single array. Here from exam perspective, map, map object and flatten are important to remember.